All right, so in today's notes, I'll be finishing off the notes for 5.1 angles and their measure. So yesterday we talked about radians and going between degrees and radians. Moving forward in trig, most often trig functions will be using radians. So it's important that we know how to still do the same things we were able to do yesterday with degrees, but as well in radians. So another new thing that will be here is we will start seeing this symbol, which it looks like a 0 with a line through it. It is called theta, and it's used to represent an angle measure in trigonometry, which remember is the focus of the semester. Number 1 wants me to find the complement. Remember, in a normal, if we were talking about degrees, this would mean 90 degrees. So if I think, do I have a black pen? So if I think back, and I'll talk about unit circles more in depth later, but if I have a unit circle like this, typically it goes 0 degrees, 90 degrees, 180 degrees, and 270 degrees, and then 0 when it completes the circle is 360 degrees. So if I think about this as radians, remember I'm going to start off and that's going to be 0 radians, and I'm going to end at 2 pi radians because a complete circle is 2 pi. So I want to break 2 pi up into 4 sections. So if I divide 2 pi by 4, 2 divided by 4 simplifies to 1/2. So this gives me pi halves for 90 degrees. 2 pi divided by 2 is just pi. And this is 3/4 of the way for 270. So I would take 2 pi times 3/4. I will multiply this one on my calculator. So I'm going to do 3/4 times 2 and leave out the pi. Ooh, that glare. Which gives me 1/2. So if I turn this back into a fraction, is 3 pi halves. Which isn't so important for today. So if I'm talking about complements, I want the radian measure that is congruent to 90 degrees. This is pi halves. So what I'm going to do is I am going to take pi halves and subtract my pi twelfths to figure out my complement. What I can do is I can temporarily pull out my pi's, so I can type this into the calculator. So what I'm going to type into my calculator is 1/2 minus 1/12. And then I want to turn this back into a fraction, which gives me 5/12. So when I get this answer, I want to remember I took out a pi when I was typing it in, so I need to put that pi back on the top where it belongs for my final answer. Okay. And the reason this works is because I could have factored this out and I could have written it, let's use red. Could have written it like this with a pi out front. And then I just redistributed that in after I typed in the part in parentheses into the calculator. So number 2 wants me to go ahead and find the supplement of 5 pi 6. What I want to do here is supplement is normally 180. If I'm talking about degrees, I want to match up to what 180 is on my circle, which here is pi. So I'm going to use pi to subtract, and I wanted to write in blue. And I'm going to take away 5 pi 6. So again, I could pull out the pi. And I just have, remember, anything divided by itself is 1 minus 5 6. I can type this into the calculator. Turn it back into a fraction, which gets me 1/6. So if I put my pi back in, 1 times pi is just pi. So my answer here is pi 6. Number 3 wants me to find a coterminal angle. Remember, this is a complete circle away. Let's use the word rotation. So a complete circle in radians is 2 pi. So I'm going to take the 17 pi 6 and add 2 pi. Again, I want to pull out my pi's and focus on adding the 17 6 and 2. 17/6 plus 2. Turn it back into a fraction, which gives me, oops, that's off the screen, 29/6. And I want to put back in my pi on the top. Because it didn't tell me if my coterminal angle had to be positive or negative, I could have also subtracted 2 pi, and that would have been fine as well. On these kinds of questions, if I don't specify that I want one positive and one negative, you can go in either direction, and as long as you do the math right, I will mark you correct. So what I want you to do right now is I want you to pause the video and then take a few minutes to work on the next 3 problems. Once you think you have answered them all, talk to everyone sitting at the group with you, compare your answers, make sure you've all got the same answer, and once you do, you can resume the video to watch the next section. So the next thing we're going to talk about is arc length. This is, if you remember back in geometry when you first learned about circles, you learned that the outside distance of a circle is called its circumference. An arc length is just the portion of the circumference that is covered by the angle you care about. So if I take a look at this picture, I am looking for the arc length that is covered by the angle measure of 240. The way I can figure this out is by using the formula S equals pi, nope, there is no pi in that formula. S equals r theta, where S is the arc length, r is the radius, and theta is the angle measure in radians. So I want to remember, oftentimes it will give it to me in degrees. Always convert to radians. So if I take a look at number 7, this one tells me a circle has a radius of 4 inches. It wants me to find the length of the arc intercepted by a central angle of 240 degrees as shown. Sometimes you may see this kind of problem without a picture. If I didn't have this picture, I could still do the math because it gives me the radius and the angle. So my radius here is 4, and my angle is 240, but that is not in radians. So the first thing I want to do is I want to convert 240 degrees into radians. So I'm going to take 240. Remember my conversion factor from yesterday is pi over 180. So I could rewrite this as 240 over 180 times pi. Then I'm going to take the fraction that is out front and simplify that on my calculator. So 240 divided by 180. Then if I go math fraction, it gives me 4/3. So I have 4/3 pi. And then I want to plug into the arc length formula. This is going to be S equals r for my radius, which here was 4, times my theta, which is my angle in radians. So 4/3 pi. And this question wants me to round to the nearest hundredth if necessary. So for this question, I will be typing the pi into the calculator. I have 4, parentheses 4, oops, I wanted 4 pi. So to get pi on the calculator, I'm going to go second, which on my calculator is this blue button right here. And then pi is right above this exponent caret button. So then I press that. Then I divide by 3, close off my parentheses, and press enter. This wants it to the nearest hundredth, which is 2 decimal places. So my answer here is 16.76. And this was measured in, doesn't say, units. Usually if I had a unit on my radius, oh, it did say. It told me in the problem it was inches. So whatever my units are for my radius will be my units for my arc length. Okay, so again, take a few minutes, or pause it, then take a few minutes to work on number 8, compare with everyone around you, and once you finish, you can resume the video to continue the notes. So So the next thing we are going to talk about is linear speed. Linear speed is measuring how fast something is moving. And then the other thing we're going to talk about is angular speed, so how quickly the angle measure is changing. So linear speed is useful if I want to see something like a fly on a fan blade and how fast it's traveling. Angular speed is good for when I want to talk about rotations and how fast something is spinning. So I have these two formulas here. For linear speed, I have arc length divided by time, so that's just s divided by t. And then angular speed is my central angle, which is my theta, divided by time. So number 9 tells me the second hand of a clock is 10.2 centimeters long, as shown. Find the linear speed of the trip of this second hand and round to the nearest hundredth if necessary. So this one is looking for linear speed. I am going to find my arc length. So for this problem, I am going to figure out my arc length. So this is the S formula. I know that because I'm just talking about the second hand, and I know it is traveling a complete circle. This is going to be 2 pi. And then my radius here is the length of the hand, which is 10.2. So then I will leave this in pi for now. I'm going to have 20.4 pi, and that is centimeters. And then to plug into my linear speed formula, I want to divide by time. And it was... So because it's a clock, it's going to take a full minute to travel around. I don't know why I was getting stuck there. So I know that 1 minute equals 60 seconds. So I can go ahead and write this out. I'm going to have 20.4 pi divided by 60, and this is centimeters per second. So then I just want to go ahead and type this into my calculator. I have 20.4 pi divided by 60, which gets me, what am I rounding to? It helps if I don't cover this, 100th. So this is going to give me 1.07 centimeters per second. Okay, so again, pause the video, take a few minutes to work on the next question, compare your answers with those around you, and then once you guys all have the same answer, move on to the rest of the video. Okay, so our last question is asking for both angular and linear speed. On this one, it tells me the blades of a wind turbine are 116 feet long. The propeller rotates at 15 revolutions per minute. One thing I want to point out is I think sometimes on homework and maybe on the test, you'll see this abbreviated as RPM. So just remember that the R stands for revolutions, or rotations is another way to think of it, per, and then the M is minutes. So that is telling you your rate at which it's spinning. So for this, I want to first find my angle that I care about. I know that there are 15 revolutions, and each revolution is a complete circle, so 2 pi. That will make my angle 30 pi. So then for angular speed, I will plug into my formula. This is my central angle. So I'm going to have 30 pi radians. And this one just wants my answer in radians per minute. So each revolution was already in minutes. This will give me 30 pi divided by 1 is just 30 pi radians per minute. So whenever it asks for radians per minute, I want to make sure that I don't type this out as a decimal and I leave it with the pi. B is asking for the linear speed of the tips of the blade, and then it wants me to round to the nearest whole number. So remember, my S value is going to be the central angle, the central angle. So the 30 pi times my radius, which here was 116. And sorry. So I'm just going to leave the pi in there for now. If I multiply 30 by 116, gets me 3,480 pi. I'm going to do the same thing for my time. I just know it's 1 minute. So then for my formula, I'm going to do 3,480 pi divided by 1. And this was feet over minutes. So then if I type this into the calculator, because this one wants it as a whole number, I will do 3,480 times pi, which gets me 1,930. I'm going to round up because the number after the decimal is more than 0.5. And this is feet per minute. So one thing I want to point out is on the homework, sometimes it changes from minutes to seconds, but it will give you the question in minutes. When it does that, you will need to convert from minutes to seconds, kind of like we did back on number 9. So once you finish this video, take a few minutes to work on number 12. Make sure you and your classmates can agree on those answers, and then you are free to work on the assignment. Just like yesterday, if you finished in class, you can turn it into the teal bin that is at the back of the room by the calculators. Today, if you don't finish, you can turn it in tomorrow when you get into class.